We want to determine the x-coordinate of the point of inflection where the graph of f changes from concave down to concave up. That means we want to determine where f double prime changes from a negative to a positive. To find the second derivative, we first do the first derivative and then the second derivative. And I have a negative sign factored out to more easily see this. F double prime is equal to 0 when sine x is equal to negative cosine x. Or you might say when tangent is equal to negative 1. Now, you can do an entire number line like I have shown over here over the domain that is given. But when you're dealing with a sinusoidal function, it is easier to use a unit circle instead of a number line and realize that in between the places on the unit circle where the equation is equal to 0, it cuts it into two sides. And each side is either giving a positive for the second derivative or a negative for the second derivative. And what can make this go a lot faster is to recognize that in quadrant 1, all trig functions are positive. That means sine x plus cosine x is positive. You multiply it by a negative 1 and it's negative. Boom. Over here, on this side of the unit circle, it includes all of quadrant 3. And in quadrant 3, sine and cosine are both negative. So if I add two negative numbers and then multiply by negative 1, that's going to be a positive. So I can really quickly see the negative positive issue. Now I want to know when f double prime changes from negative to positive. So as I make a counterclockwise motion around the unit circle, that occurs at this angle between 0 and 2 pi, which is 3 pi over 4. So 3 pi over 4 is the answer.